Now that we have the chi-square value, we need to find our degree of freedom because we eventually need to find the p-value. So remember, with degree of freedom, when it's not a two-way table setup, especially not a complicated two-way table, what we do is we take the number of categories and we subtract it by 1. So we have 4 categories minus 1, so our degree of freedom is 3. And we need to use an online calculator to find our p-value. So we enter our chi-square value, which was 5.57. Our degree of freedom is 3. Keep the significance level at 0.05, and then calculate. So we get our p-value of 0.134511. And from here, we need to make a claim, or we need to make a statement about the claim. So I'm going to say that, remember, we always compare the p-value to alpha. So 0.1345 is greater than 0.05, which is our significance level. So when our p-value is bigger than alpha, HO is supported. The initial claim is HO. So HO is supported here. So that means that the initial sales estimates, so Apple's claim, we can say that Apple's claim is correct. Right into question 2. This was from the 4-2 assignment. This is where we started getting into two-way tables. So in this one, this guy claims that there's a correlation between owning a red car and being pulled over. To test his claim, you survey 1,000 car owners and compile the results. So we can see here red cars versus not red cars, being pulled over versus not pulled over. And here's all of his observed data. Remember, this is actual data. We need to find the expected values. So remember, to find the expected values in a two-way table, you change one of the total columns to a percentage column. And then I want to find the percentages. So what's the percent of people who were pulled over, and what's the percent of people who were not pulled over? Well, to find the percent of people who were pulled over, you take the 750 people who were pulled over and divide it by the 1,000 people total. That gives you 75%. You do the same thing for the percent of people not pulled over, or you could just do 100% minus 75%, which is 25%. So there are my percentages. That's done. Next, I'm going to enter the 600 and the 400 here because those stay the same. Now I need to find the expected value of red cars who were pulled over. Well, to do that, you just take 75% of 600. Okay, you kind of do like the intersection. So 75 and 600 gives you this box right here. So 75% of 600 is 450. If you want the expected value of red cars who were not pulled over, you would do 25% of 600 because that's this box's intersection, 25 and 600. So 25% of 600 is 150. If you wanted not red cars that were pulled over, you would take 75% of 400. So 0.75 times 400 is 300. And lastly, not red cars that were not pulled over, 25% of 400. So 0.25 times 400, which is 100. These are all of my expected values. And now all that's left is to fill out your table. So I'll probably do most of the table off camera just to save a little bit of time. But that is the last thing you would do for this problem. You just fill out the table and then find your